This is the FlexRC Nano X micro quadcopter, and it is seriously one of the coolest quads I've ever built and flown. Like a lot of people, I fly 5-inch outside, and I think that's fantastic. But for times when I can't fly outside, either too dark, too cold, too wet, too hot, too lazy, whatever, being able to fly indoors is very important to me, and it is for a lot of people. So as indoor micro quads took off about 1.5 years ago, a lot of people went with the famous TinyWhoop, which is a great design, great build, but it does have some deficiencies. Namely, it's using brushed motors, which are a lot weaker than brushless motors and a lot more fragile, and certainly don't last as long. They need to be replaced periodically. And they have a lot less power, so the quad just doesn't have the power to do a lot of things indoors that people would like to do. Yeah, it's great for flying around underneath your table, behind your couch, that kind of stuff. But if you want to do some indoor acro and really rip around, brushless is the way to go. And people have tried brushless indoor quads in the past and have never really gotten the design right. Too big, too slow, too fragile, whatever. And I think that Dimitri at FlexRC has really gotten it right with the Nano X. So let's get into the actual components and then go into a detailed build. It's a 57mm motor-to-motor frame with a 1.5mm thick base plate. I'm going to put a stock inductrix frame on top of it so you can see exactly how small this thing is. It's actually smaller motor-to-motor than the stock inductrix frame, and even with the prop guard you can see it's going to be about the same size. It's built on a 1.5mm plate that's got this nice silver finish. Some other features of the frame that are pretty interesting: it uses 4 bolt holes for 11mm size motors, or it uses the new 3 bolt hole pattern for the 7mm size motors, so it's pretty flexible in your motor choice. It also allows you to mount 16x16 electronics in the center, or 20x20 by mounting them at a 45-degree angle. So pretty flexible design on this frame. It allows you for a lot of different component choices. The prop guard is supported by 4 carbon fiber arms, and there's a bottom plate that's going to help protect our ESC and allow us to mount the battery. For electronics, I'm going to use the TinyPepper 1S Cube. This is also available on the FlexRC website. It's got a 4-in-1 4-amp ESC, a FreeSky receiver, and an F3 flight controller. I'm probably going to swap out the JST connector that it comes standard with for that XT30, because that's what I'm using on most of my micro builds. One of my favorite features of this build is the FlexRC 1102 16,500 kV motors. These are tiny little motors and super fast in kV. They're actually faster than the stock brushed motors that come on an inductrix, so it should provide quite a bit of power, much more reliability, and much more durability. We're also going to spin larger props, so even though it's the same size as the inductrix, as I said earlier, we're going to spin 1535 props, which are about 38mm in diameter, versus the standard TinyWhoop props that you can see here. So same size frame, but more powerful motors with larger props should be quite a fun build. Also going to use the standard micro all-in-one camera with a 3D printed camera mount. So let's get to the build. Here's the approach we're going to take to the build. First step we're going to do is attach the prop guard mounts to the frame. These are press fit and a very, very tight fit. We're going to attach those to the frame before we install the motors, because we do need a bit of room and some flexibility in order to get these to press fit in. Because you can see there's plenty of room once they're installed to access the screws to mount the motors. So once the prop guard supports are installed, we're going to install the motors onto the frame, and then once the motor is installed, we're going to install the electronics. Now, even though this TinyPepper cube comes so nicely assembled, we're going to disassemble it and reassemble it so that we can place the ESC underneath the frame and protect it with this bottom plate, and have the flight controller on top of the frame. Finally, we're going to install the 3D printed mount for the AIO camera on top of it. Install our props and then give it a test fly. So as you can see, I've got one of the prop guard supports installed, and definitely a press fit and definitely very tight, but you can see that once they're installed, you'll have plenty of room to access the motor screw holes to mount the motor. So we're going to do these first because you do need to bend the bottom plate right at the motor mount to get these to fit in, and it's much harder to do with the motor installed. So we're going to install the guards first, and the guard supports first, and then the motors. Best way I've found to do it is to use a pair of pliers and press fit the back, the part towards the center of the frame, in first, and get that in as tight as you can. Pull it forward towards the end. Use the pliers to squeeze it into the slot as tight as possible. Once you've got it in about as far as you can go, and you can see there's a gap right here that that you're trying to slide the base plate into. Once you've got it as far as you can go, then just pinch the end with the pliers and squeeze it until it pops in. And it's a very tight fit. You got to squeeze very hard. So you see we've got 3 of the 4 prop guard supports mounted, and before I mount the 4th one, I do want to share a little tip to make this a little easier. So when you're installing these supports and you start with the back and work towards the front, you can see that the cutouts in these clips are very shallow. So one thing you can do to make it easier to install is to use a file, and I'm using a needle file, which this came with an alien frame, and file out this area of the support a bit to allow it to move forward and closer to the forward mount. So another tip is to take a flat file, and you can actually file this rounded piece even flatter to make it easier. Sorry, this rounded piece here to make it even easier to snap in, because this is a very tight fit, and if you're not extremely careful, you've got a really good chance of snapping the carbon at this very thin point. So I'm going to go make this filing, and I'm doing it under running water, so I'll cut here and come back after it's filed. So again, all I did was file the inside of the first notch, and I used this small needle file at first and made it smaller, but you can actually use a flat file. If it's got a really thin edge, you can do the same thing, and I'll try to get this in camera correctly, and file up and down in this direction to make that slot a little bit deeper. And then I also took this curve down just a little bit. Didn't need a lot of filing at all, but just a little bit to make it snap into place a little easier. So with that done, let's get the last prop support in, or prop guard in, and then we can start attaching the components. So as you're pushing this in, what you want to do is make sure you've got the notch as far forward as you can, as far towards the end of the arm as you can, because that's what's going to give you the distance you need to snap this piece in. And I use a pair of needle nose pliers and just grab both the arm, the actual motor mount, and the prop guard arm, and squeeze them together, and it should just pop in nice and gently. And it's in. All 4 prop guard arms in place, and I'm going to leave the prop guard itself off until after the build's complete, just to give me more access to the sides. Okay, next let's talk about how we're going to mount the electronics. Talking to Dimitri at FlexRC, the original design that he used when he first built his was to mount the ESC underneath the frame and the flight controller on top of the frame, using this plate underneath the very bottom to protect the ESCs. But in communication with him since then, he thinks the better way to do it may be to mount the actual flight controller underneath the base plate, and then mount the ESCs on top. So that's the way we're going to do it. But the first step is we've got to take apart this nice little flight controller and ESC package as it was sent, which is a shame because it looks like it's pretty nicely soldered. But let's go ahead and take that apart, and then we'll start putting it back together. Okay, with the flight controller and ESC separated, we can get an idea how this is wired up. And in fact, there's a fantastic wiring diagram for the ESC and flight controller on the FlexRC.com website. So you can go ahead and check it out there. But basically, you've got the 4 ESC signal wires numbered from inside to outside, 1 through 4. So green is motor 1, yellow motor 2, blue motor 3, and orange motor 4. Note that the button for binding the built-in receiver is on the bottom of the flight controller. So the flight controller's upward orientation is like that. Also note that when installing any of the electrical components into the frame and into the protecting bottom plate, I used my needle file again to widen these holes a little bit. These nylon screws are, these M2 size nylon screws are very, very fragile and very thin, so I didn't want to risk pushing them through or threading them through, so I just widened that hole just a little bit with the file. So our plan is going to be to run the flight controller below the main plate, and then the ESCs, the 4-in-1 ESC above. Now to do that, you can see that these motor signal wires are fairly short, so but the power wires for the flight controller are fairly long. So what we're going to do is desolder the 4 ESC signal wires, run them through the bottom plate, and then solder them back to the flight controller. Now, we probably could just use longer wires and run them around, but since I've got a desolderer anyway, I'm going to run them through the hole in the center of the base plate. So let's get that done. So I've got the flight controller secured with some blue tack here, and we're just going to pop the 4 signal wires off the flight controller. I'm going to start with the yellow one just because it's the most accessible right now, and it's not going to take a lot of heat or a lot of time to pop these off. I'm running 400 degrees Celsius on my soldering iron, so these come off fairly quickly. And again, you can refer to the wiring diagram that's on the FlexRC website too, so you don't have to remember where these wires came off. So now I've got my flight controller ESC signal wires separated from the flight controller. Like I said before, I'm going to leave the power and ground wires connected because they're long enough to wrap around the outside of the frame, and I really like the way they were soldered on and don't feel like having to do that again. So I've got my ESC signal leads soldered back to the flight controller, and I did misspeak earlier. The actual color direction is correct, but I talked the motor orientations is different from what I said earlier. So it's green, yellow, blue, orange from the outside, but those are motors 1, 3, 2, and 4. But as long as you get the color direction right, it'll still match the diagram on flexrc.com, so you should be okay. So with our flight controller soldered, and you can see I ran 2 ESC wires through one side and 2 through the other. That'll give us a lot more slack to play with as we mount the components. So I am going to mount the flight controller upside down. Remember the button is the bottom of the flight controller, so we're going to mount the flight controller this way, which leaves the pads on the top, again giving us more room for the wires. You could run it right side up if you swap the wires out for longer wires, but I wanted to use the ones that came with it. So the first thing we're going to do is we're going to mount the bottom plate with nylon screws and spacers. Then we're going to have the flight controller, another set of spacers, the bottom plate of the frame, a third set of spacers, the ESC, and then we're going to top it all off with this 3D printed camera mount, which is actually really well done. So if you look closely, you can see that the 3D printed camera mount actually incorporates spacers into its design, and these are threaded, so we don't need to add a nut on top of our stack. Instead, all we need is a few threads of the nylon screw exposed, and we can thread it right onto this camera mount. The last thing we need to do before we assemble, though, is we need to power up our all-in-one FPV camera, and I'm going to take the power directly off the LiPo leads. So I'm going to solder camera leads onto the positive and negative right here, which will give me plenty of room to wrap the camera lead around the bottom of the ESC and attach it to the top. Okay, we've got our electronics mounted. I need to fit that camera into the mount a little better, but you can see it all went together fairly well. Single screw with as short of spacers as I could use. Upside down flight controller, so I'll need to modify that in Betaflight, and then right side up ESCs mounted on the top. So next, all we've got to do is install our motors, solder to the ESCs, and install the prop guard. Okay, with the center stack and electronics mounted, next it's time to mount the motors. And like I said earlier, I'm using these fantastic little FlexRC 1102 16,500 kV motors. And the great thing about these motors is, believe it or not, they come with actual silicone stranded wires. So unlike most of the other 11 series motors that I've used, these come with fantastic wires. And I'm telling you, it makes a huge difference when you're mounting them, especially because we've got such a small little area to solder, and we're going to do some weaving of the wires in and out. Having real wires matters a ton. So for example, this is my FlexRC Ascent, which I'm going to do a review on later, but this is maybe the best micro frame I've ever used, using the new RunCam Micro. But anyway, this uses the Racer Star 1103 10,000 kV motors, which have solid wires with, I don't even know what kind of insulation it is, significantly harder to solder and to manipulate than the stranded silicone insulated motors. So this should make it a lot nicer to install. So what we're going to do is we're going to mount actually the first thing we're going to do is route the wires, and for each motor what I'm going to do is mount them along the arm. I'm going to go underneath the ESC and then out the back or the front depending on which motor I'm using, and then wrap around to solder to the pads. That should keep the wires fairly contained, and with a little less chance for it to snag on something. I could go directly to the ESCs, but I do want to kind of route it and make it a little bit of a cleaner build if I can get that to work. Another option that I've used a lot is to go underneath the camera mount, but as you can tell, this camera mount is mounted very, very closely to the ESC. There's very little gap in here to run wires. So I'm going to try to run under the ESC and around the top. What I'm going to do is thread them in first without trimming or screwing them in, measure it to length, cut it, solder it, and then screw the motor down so that I've got as much of the wire to work with as possible without trying to manipulate a tiny little wire around this bend while the motor's screwed in. So let's give it a shot. So this spaghetti looking mess is actually working out pretty well. Got the wires for the motors routed under the ESC so that I can then trim them to length and wrap them around the ESCs to solder the pads. The motor layout for Betaflight 1, 2, 3, 4, and the pads on this ESC line up appropriately. So these 3 pads are for motor 1, which the signal wire for motor 1 is the green wire. Up here is to the front right is motor 2, which is the blue wire. Left rear is motor 3, which is the green wire, and front left is motor 4, which is the orange wire. And then so we're going to tin these pads, solder the wires in, and then lastly screw the motors down. So as you can see, I've got all 4 motors soldered to the ESC by routing the motor wires around the standoff, under the ESC, and then back around, and then pulling them tight to mount them. I'm using the smallest screws that came with the FlexRC motors. I don't think these are designed to hold the motor to the frame. I think they're probably for holding propellers to the motor, but they're nice and short, and I want to make sure I don't hit have the screws touching the motor windings. So they're working pretty well. I've got 2 in right here. So I'm going to go ahead and install the rest of the motors and then hook it up to Betaflight. Make sure they're spinning in the right direction and calibrate them. So it's pretty much put together, but there's a couple of things that I did differently now that I've had a chance to work with it a little bit more. So the first thing is, if you'll notice here, I took the heat shrink off of the motor wires because the tab for the prop guard mounts pushes up through the frame, and maybe you can see this if I show it sideways, pushes up through the frame and prevents, actually pushes the motor wires up into the motor bell, preventing the motor from spinning. So I took that heat shrink off and I split them. I don't know how well you can see that, but I put one of the wires passing on one side of the tab and then the other 2 passing the other. There may be a better way to wire this in, but I think it's going to work, and it's still, the wires are still pretty well secured in there. The second thing I did was I changed the way I mounted the bottom plate. I rotated it 90 degrees so that the longer tabs are along the arms, leaving the shorter tabs on the sides, and that was done to allow me better access to the USB port. So I actually snipped off one of these mount holes here with a pair of diagonal cutters and then filed it down just a little bit so I can have easier access for the USB port. So with that, we're ready to put the prop guards on, mount the props, and give it a test flight. I've got the prop mount guarded, and it was very easy to mount. It didn't require any filing, and it just snapped right in. So I just started with one side, or with one guard, mounted the two side ones, and then mounted the one across from the one I started with, and then it snaps in there very, very well. And again, this requires no hardware, so very easy to install, and certainly very lightweight. So she's done, looking pretty good. A couple of fit and finish comments to make. As you can see, I swapped out the JST connector with this pretty cheap looking connector, but I use that because that's what came on my battery. I'm going to probably swap it out later on. I just don't know what battery I want to use yet, so I'm planning to use this 600 milliamp hour one cell. But I've also got these 205 milliamp hour one cells that they all have the same connector. So in the short term, I'm going to keep this connector on there. I'll probably swap it out for an XT30 once I decide what battery I'm going to use. I also attached a small piece of Velcro to the bottom, which is also attached to the bottom of the battery. And I need to figure out what I want to do for a battery strap. So FlexRC has these really cool looking straps that they include with some of their kits. Obviously, this is designed for a much larger frame. It'd be great in a 3-inch, but probably a little too big for this Nano. So I may just loop some rubber bands around these tabs here, or I may run a much smaller Velcro around the ESCs and just wrap it around the bottom. So we'll see about that. But looks good. I've got it. I set it into beta flight. Everything looks good in beta flight. I did reverse the roll on the flight controller orientation, so because I did flip it, so I just did a -180 on the roll axis. And motors checked out. The motors did these. These are these very high kV motors. They spun up at 1143, I believe, on the motor tabs in Betaflight. So I set my minimum motor to above that, to about 1170, and that gave me a nice spin up when it was at zero throttle and armed. So now let's take a look and see. Actually, let's do a size comparison first, so you can see. This just amazes me how small this thing is. So with brushless motors, we're about almost exactly the same size, and actually, if you can look at it from the side, it's a little shorter than an actual tiny whoop. And let's take a look at how much it weighs. So we're at 32.1 grams with no battery. I think most people know most tiny whoops are coming in under 20, so that's at 19.9. So we're at 32.1, 32.2 with the 600 milliamp hour battery. It's going to push it up to 47.1, and with the 205, that's down to 40. So a 40 gram brushless build is a pretty sweet combination. So going to give it a test fly, and then let everybody know how it works.